Okay, so let's go ahead and go through these notes. So when we're talking about inverses, we're trying to do this because we want to think of being able to undo a process. Okay, and so we call that an inverse. And I just want to remind you that this is different than a reciprocal. So we're not just putting one over the function, we're trying to find a function that kind of undoes our function. So our first task, example 1 here says, determine which functions will have an inverse. That's also a function. If it won't, show how to restrict the domain so the inverse will be a function. So if we look at example A here, if we want a function that undoes a function, we would create a table and we could say, okay, well, we put in x to this function, we put in -2, we get out 3. So our inverse function, so if we call this f of x, our inverse f inverse of x, we would want to put in 3 and get out -2. We'd want to be able to put in 1 and get out -1. We'd want to be able to put in 2 and get out 1. Now here's kind of a problem. Here's another place where we got 3 out of the original function, so we might want to say, well, if we put in 3, we want to get out 4. But we already said if we put in 3, we get out 2. So this causes a problem. And so we need to restrict the domain, just like we did with trig functions earlier. And we could do this lots of different ways. So we could restrict the domain by not including -2, or we could have made the choice to not include 4. So if we didn't include -2 in our restricted domain, then 3 wouldn't equal -2 in our inverse. 3 would equal 4. Okay, so let's look at the same thing for B. So here we have the cosine function, which we've dealt with last semester. And remember, with cosine, to find arc cosine, we restricted the domain from 0 to pi. So here, our restricted domain was from 0 to pi. And remember, that became our range of our arc cosine function, of our inverse function. Okay, and then here our function f of x equals x squared minus 1. Well, we might be able to, let's think of some points here. For example, if we put in, let's say -2, we would get out 3. If we put in -1, we would get 0. 0, we'd get -1. 1, we'd get 0, and 2, we'd get 3 again. And if we think of the parent function x squared, the -1 here is going to transform it by moving it down. We can notice that if we did kind of the swapping like we did over in part A, we'd run into problems. So for -2 and 3 and 2 and 3, right? In our inverse, if we put in 3, would we get out 2 or -2? And if we put in 0, would we get out 1 or -1? And so with our square root function, we normally restrict the domain from 0 to infinity. So we would ignore those. So when we put in 3, we would get out the positive value 2. And when we put in 0, we'd get out the positive value 1. Okay. So all of these problems that happen where we have to restrict a domain come from a function not being what we call one-to-one. And so the kind of precise way of saying a function is one-to-one is by saying if one x value does not equal another x value, x2, then their y values don't equal each other. Right, so what we're saying here is each x value has a different y value. And the test that you've probably heard before, or a way that you can look graphically at a function to see if it's one-to-one, is here this is the same as saying it passes the horizontal line test. So example 2 here tells us how we find, if a function is 1-to-1, how we find the inverse function. And so our first step is to switch the x and the y. Remember, the y comes from f of x. And then solve for y. So let's go ahead and do that here. We have f of x equals 3 log base 2 of x minus 4. So we'd say y equals 3 log base 2 of x minus 4. I like just changing that to y before I switch. Then we're going to switch our x and our y. So we'd have x equals 3 log base 2 of y minus 4. Now in a minute we're going to use our property of what logarithms mean. But before we do that, we want to isolate the log expression on our right hand side. So we're going to divide both sides by 3. We'd have x over 3 is log base 2 of y minus 4. So now we can use what logarithms mean. And what this means is 2, our base here, to the x over 3 power equals y minus 4. So this is a reminder of how we solve equations with logarithmic functions. And now we can add 4 to both sides. Isolate that y. And so now we know that our inverse is equal to 2 raised to the x over 3 power plus 4. Okay, over here we have a rational, so for part B we have a rational function. F of x equals 2x minus 1 over x minus 2. And so again, I'm going to start by saying y equals 2x minus 1 over x minus 2. And I know we say switch the x and the y. Maybe a more precise way, sorry, I'm heating up the oven for dinner. Maybe a more precise way of saying it is that we replace y with x and any x's with y's. So we're going to say x equals 2y minus 1 over y minus 2. And now it's really algebraic manipulation that you've done many times in the past to solve for y. I'm going to multiply both sides by y minus 2. So x times y minus 2 equals 2y minus 1. I'm going to distribute the x. And I'm trying to solve for y. So kind of a general strategy, and you'll do this next year in calculus when you're doing problems and you're trying to solve for things, is whatever we're trying to solve for. We're trying to solve for y here. We're going to get any term with a y on one side and any term that doesn't have a y on the other side. And that way we can factor out a y and solve for y. So I'm going to get y's on the left-hand side by subtracting 2y from both sides, and anything else on the right-hand side by adding the 2x. So that will give me xy minus 2y equals 2x minus 1. And now both terms on our right-hand side, sorry, left-hand side have a y, so I can factor out a y. And I can now divide by that x minus 2, so y equals 2x minus 1 over x minus 2. And so y, remember, is now our f inverse function, so I can say f inverse of x equals 2x minus 1 over x minus 2. Okay, I'm going to pause or stop this video here and make another video for the back of the page. That way these don't become too long.